There has been a launch recently of a probe which is going to monitor the solar wind. The heliosphere, what's that? Basically the area reached by the solar wind. It is a giant magnetic bubble which is around the solar system created by the solar wind, which goes maybe 3 times the distance from Sun to Pluto beyond that. Solar wind is a stream of charged particles, plasma, coming from the sun. And in the process of that, it creates a lot of radiation and magnetic fields just from the fact that you got moving ions. You get some of that. It's important to us because it does protect us from some cosmic radiation. There's a better picture of this from an explanation standpoint here, the heliosphere. And it's kind of like a comet in a way, except that the solar system is the comet. It's moving around the core of the galaxy. As it moves along, what happens is the solar wind goes out, and you think of everything out in space as being almost nothing, but that's different than nothing. And it exerts a pressure. And what happens is as it goes farther and farther from the sun, it eventually really hits the static pressure that's pushed back just by what's around us, totally around the solar system. They call that the interstellar medium. Not much to it, but it's enough. And so you get kind of a shockwave kind of effect, where the solar winds, basically all the charged particles, they kind of pile up because they're getting slowed down. They're going really fast, and as they get up toward the edge of what's called the heliopause, they really start to kind of pile up. Just like water, it's going really, really fast, and it suddenly slows down, it kind of builds up a wall. Well, it changes potential energy. Well, in their case, that energy switches to thermal energy. It gets hotter. That whole area does that. And then actually, even coronal mass ejections, other particles coming out from the sun, most of them get caught up in this, and then they kind of flow around, and you end up getting most of the material coming out of the sun ends up kind of trailing behind it, kind of comet-like, because of the resistance from the interstellar space around us. This picture is just showing that. So they still want to know a lot more about this. They've been studying this, and they keep finding out new things. And there's a new probe called IMAP, for Interstellar Mapping and Acceleration Probe. And its goal is just basically to understand all this stuff better. Space weather, get better warnings in particular. When there's all kinds of things going on in space, or especially in the sun, they want advanced warning when there's going to be sudden changes. It affects the astronauts, it affects the spacecraft, it actually affects communications or electrical grid, even on Earth. So all these things are monitored by this probe. It looks like this. It shows on the right-hand side of this. It was just launched on September 24th. Its orbit is around the Sun-Earth Lagrange point 1. So point 1, that's the one that's in between the Sun and the Earth, where the forces of gravity basically balance each other. So it's relatively cheap to keep an orbit going around that. It'll get there around January 2026. It's not a stable point, so it does take some propellant. But anyway, it's relatively cheap. There are currently other satellites there as well. This is a project of NASA, Goddard in particular, also with academic help from Princeton and Johns Hopkins universities. And there's actually a couple of other smaller space weather satellites going along with it. If you're going to go to the trouble of launching something that far, usually there's ride shares, little secondary payloads that go along for the ride. This thing has 10 different instruments on it. So they can track the solar wind. They can look at the interactions of the solar wind with the winds from other stars, coronal mass ejections, and they're basically measuring magnetic fields, light, particles, and dust. And I should mention that there's been a lot of things about, well, okay, space programs are being cut back. This is one the National Space Society has come up pretty strongly in support of almost all of the studies of the heliosphere because of the issue of space weather. It has such an impact in particular, as we go out into space. There's so many dangers out there that the more we know about this, the better. Okay. Other space-related videos or slide presentations by me are available at the link shown here. That includes a list of videos at my YouTube channel, so you can view them or subscribe for notifications about future videos. These presentations are mostly made as part of the meetings of National Space Society's North Houston chapter, and the link to that is shown. Topics like these are presented as part of a monthly news segment, and there are also lots of other interesting speakers and open discussions. You can attend in person or online via Zoom. Come join us.